From hydrogen power to cutting-edge propulsion, we take a look at some of the most incredible engines in development. At number 7, the Aquarius generator. This Israel-based company has developed a very impressive two-sided free-piston linear engine. It has one piston with combustion at 2 points in a valveless cylinder. The end of the rod is connected to a magnet, which moves inside coils, thus generating electricity. It's oil-free, and it only has one moving part, so there is far less maintenance, and it has an extremely high power-to-weight ratio, with a 100 kilogram unit producing around 16 kilowatts. But the company is still a ways away from actual production. At number 6, the hydrogen engine. It is no secret that Toyota is leading the forefront on hydrogen-powered vehicles. Their latest innovation ditches the fuel cell altogether and utilizes hydrogen as a direct fuel source. Now, hydrogen combusts at a faster rate than gasoline, so both the fuel supply and injection systems had to be extensively modified. The 1.6 three-cylinder hydrogen engine has already completed a 24-hour endurance test with some pretty good results. Now, whether or not this engine will actually pan out is anyone's guess, because the efficiency rating is actually quite low for hydrogen ICE cars. Nevertheless, Toyota has remained focused on advancing hydrogen-type vehicles, and it's going to be really interesting to see what happens in the next couple of years. At number 5, the UltraFan. Rolls-Royce is currently working on one of the biggest jet engines to ever be produced. Now, the company claims that it would provide a 25% uptick in fuel efficiency over the first-generation Trent turbofan. Several features include carbon titanium fan blades, advanced ceramic composites, and a geared design which delivers efficient power for high-thrust bypass ratio engines. Work is already being done on its fan system and its powered gearbox. Ultimately, the engine will produce up to 110,000 pounds of force and become available around 2025. At number 4, the rotating detonation engine. Now, I mentioned this one before, but there is currently a race to build the first usable rotating detonation rocket. This is a step up from pulse detonation because waves cycle around the chamber instead of being purged after each pulse. As a result, there is a continuous explosion fed by oxygen and hydrogen, but these bursts can exceed 5 times the speed of sound. So naturally, there is a major challenge to keep this engine from overheating. Now, a 3D printed design might be able to actively cool these extreme detonated velocities, but a final working prototype in a vehicle is still quite a ways away. At number 3, the oblique detonation engine. So we have seen pulse detonation, which creates a series of explosions, which is also very loud. Then there's the rotating detonation variant, which is tuned within a ring-shaped channel. Thus, the explosions are more continuous and more efficient. But there's also a third type of detonation in this series, which is even more advanced. It's called the oblique detonation wave. Unlike rotating detonation waves that spin, oblique detonation waves are stationary and stabilized. So this type of design is composed of 3 sections. The first section accelerates a mix of hydrogen-oxygen up to Mach 0.5 before main detonation. This flow can be manipulated, thus giving a continuous explosion that is stabilized. The main detonation then occurs in the next section, and the flow is accelerated to a very high velocity. Now, UCF has already managed to run this detonation for about 3 seconds, but they also claim that it shouldn't be too hard to scale up in the future. We move on and look at one of the most important engines being developed right now, which is titled the Sabre. Now, this engine works like a conventional jet engine up to Mach 5. And then it switches to a rocket mode to achieve Mach 25 or low Earth orbit. It's also 100% reusable, so it can be used on a spaceplane multiple times a day. Now, Mach speeds generate enormous amounts of heat, so its precooler is designed to cool incoming air from more than 1000 degrees Celsius to ambient temperature in a fraction of a second. Now, the company has already completed testing of its heat exchanger and hydrogen preburner. Now, these components supply heat, energy, and air into the core of the engine, so there has been quite a bit of recent progression. Naturally, this kind of engine would lower the cost of going to space. So it's being backed by some of the largest aerospace companies in the world, and it's very probable that it will be developed within 10 years. Now, before we get to number 1, I just want to re-emphasize my point that there are some real innovations happening right now, but I think the future of propulsion will hinge on our understanding of gravity. Once we can have a better comprehension on what gravity really is, then I truly believe we will find some type of propulsion breakthrough. This will hopefully allow humanity to diversify into the depths of space. And this also brings us to the great number 1 position. Probably one of the most amazing engines being worked on right now is the VASMIR. The Variable Specific Impulse Magnetoplasma Rocket Engine is one of the most impressive propulsion systems being developed right now. It can theoretically achieve speeds up to 110,000 miles per hour. But this is not your typical engine, and it works by injecting a gas into a helicon coupler. The gas is then converted into plasma, superheated, and ejected via magnetic nozzle. This gives the VASMIR a specific impulse upwards of 5,000 seconds at 200 kilowatts, which is exponentially higher than a rocket engine. Now, this is not going to get you into low Earth orbit or anything like that, and it's specifically intended for space applications. There is also the claim that you could reach Mars in 39 days, but you would also need some type of fusion reactor or power source which can get you into the megawatts of power. Nevertheless, it can achieve higher velocities in space, and it could be a very important key to future space travel. So once again, thanks for watching. Please like the video if you enjoyed it, and also make sure to subscribe to my channel.